I would like now to hand over to Amapola Manrique. She's working at the Virology of University of Zurich, and she will speak about the sample processing of or the processing of the sample pools. Please, Amapola.
Thank you. Just checking. Okay, so I work at the Institute of Medical Virology of the University of Zurich. We do all the testing of the CoVMass samples. So the Institute of Medical Virology has both a research and diagnostics department. The diagnostics department diagnoses many viral infections. So the beginning of January 2020, we established a SARS-CoV-2 PCR detection. We were seeing it was a major issue in other countries. And so at the beginning of the pandemic, we were the only lab in Zurich that was allowed to do these SARS-CoV-2 PCRs. So I have a graph here where we show how many actually tests we do per day from the beginning of the pandemic till now. In mid-March, other labs were allowed to test as well. So this gave us a relief, as it was quite stressful in the beginning to ramp up and to get everything set up. Right now, we're again in a phase where we have less samples. And so things have calmed down a little bit. So the diagnostics department also do antibody measurements. We do viral culture for SARS-CoV, neutralization assays, genotyping, sequencing, and all of that. So you can see here actually in the graph that there's some peaks of testing. We'll talk about this, but these are basically outbreak tests in schools. So the canton decides when there's like a major community outbreak in a school, and so all students get tested. And so this is why actually we started thinking about implementing another material that is not the usual nasopharyngeal swabs to test SARS-CoV-2, especially in children. And if we do mass testing, we needed something that was more user-friendly and still reliable. So saliva is used in other viral infections for diagnosis, and so we did a large-scale head-to-head comparison where we enrolled 1,200 people, adults and children, together with our collaborators at the hospitals and emergency units. And the protocol we used there is what we then used for CoVMass as well. Jörg showed this quickly as well. So as you can see, out of those 1,200 participants, around 270 tested positive for SARS-CoV-2 in either NPS or saliva. So you can see that on the panel A. There was a great agreement actually, so the overall percent agreement was close to 98%, which told us that even though with saliva you have less virus in saliva than compared to the nasopharyngeal material, it was sensitive enough to be detected in a PCR, and especially suitable also when we work with children. So then the FOPH recommended doing those repetitive tests as pools. So we also then evaluated the sensitivity loss when you dilute basically your sample in a pool. We did comparison studies with different CT values, the different viral loads in the samples, and concluded that, as expected, we lose sensitivity, but we were able to detect even very low viral loads in pools of up to 15 samples. So for practicality issues for CoVMass, we went with the 8 pool as it would fit well in a depot plate. And so that's what we went for. So here, just quickly, the process in our lab. We received from NEXUS lab, we received both the pools and the individual samples as depot. The The pools then get pre-processed in our lab. So basically we scan the samples into the system, we vortex, we centrifuge, and then we use an automatic system, which is the Roche cobas machine, to run the PCR. The advantage is that it's fairly fast. It takes like 3.5 to 4 hours to do the PCR. You can load 100 samples at a time. And it does both the extraction and the PCR together. Once the results are ready, they get validated by the scientists and staff, and then you get either 3 types of result, either an invalid pool, a negative, or a positive pool. And so I'll talk a little bit more about invalid pools when we talk about troubleshooting, but basically those are pools where the machine gives us an error message that either there was an inhibition in the PCR or there was clogging. When that's the case, then we have to do a manual extraction and followed by in-house PCR, which usually actually most of the times works out. The issue there is just a timing issue, as we've done, the first 3-hour PCR automated, and then we have usually the next day we'll do the in-house method. For the negative pools and the positive pools, they get automatically reported to ETH. So the negative pools, nothing else needs to happen. The ETH then does the reporting to the participants directly. For the positive pools, we get also automatically the depooling information. So where are the individual samples that were in that pool in the default plate? And there, then in the lab, we process those samples individually. We prepare them for the cobas machine. We do the cobas, we do the result validation, and then again, positive, negative, or invalid samples. Both the positive and negative individual samples get reported to the ETH, as well as the canton and the FOPH. Nothing happens with the negative individuals. Positive individuals then get contacted by contact tracing and asked to isolate. So the invalid pools is something that actually took us a little bit by surprise. We had done in our large scale study, and in salivas, we were expecting a 1 to 2% rate of invalid pools. Turned out that we had around an 18% rate of invalid pools. So we started looking at possible inhibitors. So we in the protocol, we asked people to not eat or drink or smoke an hour before providing your sample. It's hard to control, of course, that we looked at toothpaste, mouthwash, all things like that, and didn't find anything that would inhibit the PCR. We changed communication strategy, as David just said, where we asked people really to provide saliva as opposed to sputum. There were also some changes in NEXUS lab, where how deep the pipette arm would go in to get the sample, and then vortexing this sample after adding the lysis buffer. So the lysis buffer and the saliva have some time to mix well and start breaking up the very viscous saliva that we were seeing. On our side, we started adding DTT. DTT is a redox reagent. So it basically breaks down disulfide bonds, which then helps the sample to be more liquid. So we were hoping that by making reducing viscosity and make the sample more homogeneous, that would help us out when running the PCR. So one thing maybe I should say is that with this automated PCR systems, we don't get access to the raw data. So it's hard for us to really know what exactly happened in the PCR and why it didn't work. This is Roche's own system, and so it just gives us an error message. But with those changes, we see now a 9% invalid rate when we don't add DTT. When we add DTT, it's a 3% rate, which we think is good enough. And so now routinely in the lab pre-processing step where we vortex and centrifuge, first we add DTT and incubate for a little bit before we actually put it into the cobas. Then Jörg mentioned this, as we were not seeing any positive pools, there was the worry that maybe in the process of preparing the samples, we were losing sensitivity. So we provided the NEXUS lab with 2 samples, one with a higher viral load and one with a low viral load. So the CT values are here. So the CT of 34.2 means that there's not much virus in that sample. Actually, we would probably not consider a person with that viral load infectious anymore. And then that was then sent to the NEXUS lab, who hand processed it as they usually would, together with 7 negative other samples, pipette in the robot, and then they delivered the pools and the deep well plates to us again, as we would normally do. The result here was that for the pools, both pools were positive. As we were hoping, we had lost some sensitivity because of the 1:8 dilution. However, both samples were detected, even the one with the very high CT value. And then we also checked the CT value of the individual sample, which was almost identical with what we had provided initially, which just corroborated actually the efficiency or the efficacy of the process we were doing. So just to close up, the protocol works. I think from our side, we're happy with how the process is. The invalid results is something that we'll keep an eye on. We're actually working with Roche right now to get access to the raw data. They have been seeing, Roche has been seeing as well some invalids in their saliva tests. So we're working together with them to try to figure out what could be inhibiting the PCR. We're currently processing around 100 CoVMass pools per week. And so are ready to ramp up if needed as well. The situation is very dynamic, so we're just adapting as things happen. And so finally, just to thank everybody at the Institute. As I said, it's been a very dynamic year and a half. We've hired many people to be able to cope with the amount of samples. But I mean, this process, I also want to thank the CoVMass colleagues. I've enjoyed this collaboration quite a lot. And so we look forward to see what happens now over the summer and then the next fall. Thank you.